Hello all, welcome to Next Tech with JK, where we make tech simple and easy for everyone. Today we are starting right at the beginning. What exactly is a computer? If you've ever wondered what a computer really does, how it works and why it's so important in our daily lives, this video is for you. Even if you've never used one before, don't worry, we'll explain everything in simple terms. So what is a computer?
What is a computer? A computer is an electronic device that takes input, processes it, stores it, and gives an output. Let me explain that in a simpler way. A computer is a machine that can accept instructions as input. Think and work on it as process. Remember things as store data, and give us the result as output. Here's a small example. If you type a letter on the keyboard, that's input. The computer processes that input and shows a letter on the screen. That's output. So a computer is not just a monitor or a keyboard. It's a complete system that works together to help you do tasks like writing, drawing, calculating, learning, playing games, and so on.
Before computers, humans relied on simple tools like fingers, stones, and wooden sticks for counting. One of the earliest calculating devices? The Abacus, a humble start to a revolutionary journey. In the 1800s, mechanical devices began to emerge. In 1822, Charles Babbage introduced the difference engine, designed to calculate numeric tables. Just 15 years later, he advanced this concept with the analytical engine, the first design capable of general-purpose calculations. In 1843, Ada Lovelace recognized the potential of Babbage's work. She crafted the first algorithm intended for a machine, earning her the title of the world's first programmer. By 1853, Sweden's Schweitz engine was built, a working model of Babbage's design for astronomical calculations. The 1860s saw manual calculators aiding engineers and mathematicians. In the 1870s, Thomas de Colmar's arithmometer gained popularity in banks and insurance offices. By 1889, Herman Hollerith introduced the punch card tabulating machine, marking the dawn of automated data processing. In the 1890s, the U.S. Census Bureau revolutionized data processing with Herman Hollerith's punch card tabulating machine, slashing the census data processing time from 8 years to just 1. This marked the dawn of automated data handling. As we entered the early 1900s, computers remained largely theoretical, mechanical or mathematical tools without true electronic systems. In 1904, British engineer John Ambrose Fleming invented the vacuum tube, a pivotal component in modern electronics. This breakthrough allowed for one-way current flow and signal amplification, laying the foundation for electronic computing. Vacuum tubes consist of two main parts: a heated cathode that emits electrons, and a metal anode that collects them. When heated, electrons are emitted, a process known as thermionic emission. If the anode is positively charged, it attracts electrons, allowing current to flow. If negatively charged, it repels them, halting current flow. This setup enabled the conversion of alternating current into a pulsating direct current, a concept we'll explore further in future videos. The 1920s saw rapid advancements in electronic devices, particularly in the wake of World War I. This era made clear that rise of analog computing, which utilized continuously variable physical quantities like voltage to process data. Analog computers became essential in military applications, radio communication, and cryptography. The demand for precise artillery calculations led to the creation of differential analyzers, mechanical computers adept at solving complex equations. In the 1930s, Alan Turing introduced the theoretical concept of the Turing machine. This simple yet profound idea laid the groundwork for modern computer science, paving the way for programmable computers.
During World War II, electromechanical computers played a crucial role in decoding enemy messages. These machines laid the groundwork for modern digital computing. In 1947, scientists at Bell Labs invented the transistor, replacing vacuum tubes. Transistors allowed machines to become smaller, faster, and more efficient. A transistor amplifies or switches electronic signals. It is used to build logic gates, the core of all digital circuits. Transistors also power memory cells, where high voltage represents 1 and low voltage represents 0. By 1949, computers like ENIAC and EDSAC were built using transistor-based designs. These were among the first programmable, memory-storing digital computers. In the 1950s, computers were used for military simulations, weather forecasting, and rocket trajectory calculations. Programming was done using machine and assembly languages. The 1950s also marked the birth of commercial computing machines used in government and industrial sectors. By the 1960s, computers were used for payroll, banking, and inventory management. Transistor performance doubled every 2 years, shrinking size and cost. This trend became known as Moore's Law. IBM's OS 360 operating system was deployed across airlines, hospitals, and factories, revolutionizing business automation. By 1964, computers were evolving rapidly, and operating systems emerged to manage their complexity. Three major systems defined this era. OS 360 by IBM for enterprise computing, Unix from Bell Labs, known for its flexibility, and Multics, a pioneering OS developed by MIT, GE, and Bell Labs. In 1971, Intel launched the 4004, the world's first microprocessor. This groundbreaking chip could perform tasks that once required entire circuit boards, igniting the microcomputer revolution. That same year, Ray Tomlinson sent the first email using the @ symbol to connect users even when they weren't online. This innovation laid the groundwork for modern email communication. In 1973, Robert Metcalfe and his team at Xerox PARC developed Ethernet networking, enabling computers in close proximity to communicate and share data, marking the dawn of local area networks. The Altair 8800 hit the market in 1975 as the first widely available DIY computer kit. Hobbyists began building their own machines at home, ushering in a new era of personal computing. In 1976, Steve Jobs and Steve Wozniak introduced the Apple I, a sleek, pre-assembled personal computer that transformed computing for casual users. By 1990, mass-market PCs like the Apple II and Commodore PET were launched, making computing accessible to homes and schools, changing the landscape of technology. These machines brought works processors, spreadsheets, games, and educational software into everyday life, making computers essential tools for learning and creativity.
In 1981, IBM launched its first personal computer, powered by Microsoft DOS. This was a game changer, standardizing the industry and bringing computing into homes and businesses. It was text-based but incredibly functional for those early adopters. By 1983, Apple Lisa introduced a revolutionary graphical user interface and a mouse. The following year, the Apple Macintosh made computing visual and intuitive. No more complex commands, just point, click, and go. By the mid-1980s, software like Microsoft Word and Excel became household names, transforming computers into powerful tools for writing, calculating, and creating art for everyone. In 1990, Windows 3.0 launched with multitasking and improved graphics, making software navigation easier. Just a year later, the World Wide Web was born, connecting documents globally and ushering in a new digital era. In 1993, Mosaic, the first graphical web browser, was released. For the first time, users could view images and text together, making the web engaging and user-friendly. Then came Windows 95, a massive leap forward. It introduced CD-ROM support and the Start menu, making multimedia content widely accessible in homes and schools. In the late 1990s, digital devices like MP3 players and digital cameras began shaping our entertainment. Gaming became immersive, music was portable, and photos transitioned from film to memory cards. Between 2000 and 2005, we shifted from slow dial-up to high-speed broadband. This change redefined computer use, enabling online banking, e-learning, and early social networks like MySpace and Friendster. From 2007 to 2010, the iPhone and Android phones sparked a mobile revolution. These handheld computers changed how we interacted with technology. Everything was at our fingertips, merging communication and entertainment. As computing became mobile, cloud services like Google Drive and Dropbox made files accessible anywhere, enabling remote work and collaboration. Mobile technology evolved rapidly, bringing UPI, e-commerce, video streaming, and the Internet of Things. Devices are now smart and interconnected, powered by AI. Today, cloud infrastructure is organized into service models like IaaS, PaaS, SaaS, and FaaS, providing on-demand resources and applications. From counting with stones to voice-controlled AI, the journey of computers reflects our curiosity and desire to connect. And this is just the beginning.
Thanks for watching. If this video helped you out, please give it a like and subscribe so you won't miss what's next. Have questions or ideas? Leave them below. I'll reply to as many as I can. For more in-depth tech, innovation, and digital insights, keep watching Next Tech with JK. Stay curious and connected. Until next time.